Which alcohol reacts with an acid catalyst to form a mixture of stereoisomers? A. 3-methyl-butan-2-ol. B. pentan-1-ol. C. 2-methyl-hexan-2-ol. Or D. heptan-4-ol. So when you react an alcohol with an acid catalyst, you get an alkene. So we're going to be looking for EZ isomerism. So if we start with drawing out A, so we've got butan-2-ol, so we need a 4-carbon chain, and then we have 3-methyl, so here, and then 2-ol, so our OH on carbon number 2. When we react with this acid catalyst and form an alkene, we can either form one here or here, and we get rid of this OH group. So if we look at this one, so that has 2 hydrogens, so we can't have EZ isomerism, so no EZ. And then here we have 2 CH3 groups again, so there's no higher priority, so there's no EZ stereoisomerism. So it can't be A, which we can eliminate. Then if we move on to look at B and we draw pentan-1-ol, so we've got a 5-carbon chain, and then we've got an alcohol on carbon number 1. So when we form a double bond, we can only form one, and it's going to be here. Then if we got rid of our OH when we form this alkene, we've got 2 hydrogens. So again, we've got no high priority groups. So we have no EZ stereoisomerism. So it can't be B. Then if we look at C, we have 2-methyl-hexan-2-ol. So we need a 6-carbon chain. So here, if we draw a 6-carbon chain, and then we need 2-methyl and hexan-2-ol. So that's going to be both on carbon number 2. Then when we form our alkene, we can form one here, here, and here. And we get rid of this alcohol group. So this first one, we have 2 hydrogens, so we can't have EZ isomerism. Also, on this second one, we have 2 hydrogens, so we can't have EZ isomerism. And then on number 3, we've got 2 CH3 groups, so there's no EZ stereoisomerism. So it can't be C. And finally, if we draw out D, that's heptan-4-ol. So we need a 7-carbon chain. So here we've drawn a 7-carbon chain, and we want an alcohol on carbon number 4, which would be here. And then if we draw its alkenes, we can either form one here or here, and then we will rub out this OH group. So if we look at the first one, we have a hydrogen here, so we're going to have a high priority group here, and then we have a hydrogen here, so this group is going to be our high priority group. So we do have EZ isomerism for group 1, so that's good. But we need a mixture of stereoisomers, so we need to look at number 2. So number 2 will have a hydrogen here and here, so it will have this is its high priority group and this is its high priority group. So again, we're going to have EZ isomerism. So that's really good because we've got this mixture of stereoisomers, and the key in this question was to realise that you form an alkene and the stereoisomers associated with alkenes are EZ stereoisomers. And the answer for this question is D, so to get the mark for this question you need to write D in the answer box provided.